Hello everyone, I'm Raul. My final project focuses on optimizing retrieval augmented generation for academic psychology literature toward a research-grounded mental health assistant. Today I will walk you through what problem I addressed, how I built and tested the system, what works the best, what didn't, and what I plan to do next. So large language models are powerful, but they still face major limitations. They can hallucinate, struggle with transparency, and can't always reason clearly, especially with dense domain-specific texts. Retrieval augmented generation, or RAG, addresses these weaknesses by grounding answers in external documents. My focus is on optimizing RAG for academic psychology literature, where answers must be not just accurate, but contextually grounded and analytically insightful. So my long-term vision for this project is to extend this into a research-grounded mental health assistant that clinicians, researchers, or psychology students could actually trust. For this project, I used a single psychology research paper, a 2x2 achievement goal framework. This paper is concept very heavy and logically structured, so it is a great stress test for a RAG system trying to answer abstract or analytical questions. The system architecture I built is much more aligned with the advanced RAG framework from the 2023 paper, Retrieval Augmented Generation for Large Language Models, a survey. I designed experiments across all three stages, pre-retrieval, retrieval, and post-retrieval. In pre-retrieval, I cleaned the data, removing headlines, citations, and formatting artifacts that confused the embedding model. Then I tested different chunking strategies. For example, fixed token chunking, semantic chunking, parent-child, sentence windowing. I also explored metadata enrichment, adding section headers, but it didn't improve results in the single document context. And for the retrieval stage, I compared different embedding models. I also tuned the top K values in the retriever and tested out different vector stores. In post-retrieval stage, I applied different re-ranker models like the BGE and RankGPT to improve the context relevance. I also use query rewriting techniques like multi-step decomposition to sharpen the focus of more abstract questions. Lastly, I want to briefly touch on how I evaluated this response quality, which I think is very important for comparing different RAG configurations. In early versions, I use manual evaluation. I score each response on accuracy, completeness, and clarity. This worked well for nuanced judgment, but became too time-consuming as I ended up with too many experiments. So in later versions, I added an LLM-assisted evaluation layer. I created benchmark answers for each question. And then I used a GPT-based script to score the outputs from 1 to 5 across the same dimensions and with a short justification. This made the evaluation more scalable and also more consistent. So for all of the experiments, I ended up running 6 different rounds. The version 1 focused on data cleaning. The version 2 tested embedding and prompt variations. Version 3, I applied query rewriting. For version 4, I explored different chunking and retrieval optimization techniques. For version 5, I compared the evaluation methods. And version 6, I tried integrating the top strategies with mixed results. So in general, this modular structure allowed me to iterate quickly and isolate what worked the best. The most effective setup was semantic chunking plus RankGPT reranker combined with clean input. This pipeline consistently produced answers that were more complete, accurate, and contextually aligned, especially for complex questions about theoretical constructs in experimental design. Using both manual and large language model-based evaluation helped me catch not just surface level issues, but also deeper reasoning problems that might have been missed with just one method. But some strategies didn't always work well. For semantic chunking, even though it is powerful, however, it was not stable and not deterministic. It was hard to reproduce without caching and setting the seed. The GPT-based scoring often overvalued fluency and missed factual errors. Too much transformation, like combining the re-ranking with query rewriting, could dilute the context and produce really bad results. Sentence windowing broke coherence and consistently underperformed even on factual questions. So here is a snapshot of the RAG outputs. The model didn't just list definitions. It synthesized information, compared goal types, and referenced empirical outcomes. These kind of responses are what I hope to see in a research-grounded mental health assistant. Ones that are not just fluent, but conceptually insightful and trustworthy. So for limitations, there are a couple of them. The system is trained on just one research paper, and there's no user interface yet. It's all notebook-based. Many settings either use default parameters or I just lightly tune the parameters. And the semantic chunking is non-deterministic, as we mentioned earlier. GPT evaluation showed some blind spots. So moving forward, these are what I plan to do. I want to build an RAG system that support multi-documents. I also want to keep building a working mental health assistant prototype and also explore the fine-tuning models on psychology Q&A, improve the pipeline reproducibility, also introduce human-in-the-loop evaluation with psychology experts. Thank you for watching, and I hope this project inspires more applied research into building safe, trustworthy AI tools for mental health and education.